I'm Adam Vermeer, and I'd like to give you this talk, Working with the Machine, A Maker's Journey into Clojure. I'd like to outline this talk a little bit here. This talk is more my story than anything else. It's my fascination with making, talk about my curiosity with computers as creative tools, and it features some of my excitement about Clojure. And at the very least, I hope that this talk can be encouraging to you and maybe just a little bit inspiring as well. I'd like to talk about me briefly. I grew up in southern Ontario, and I grew up in the Niagara region where there's a lot of vineyards and greenhouses, and my family has a family business in greenhouses. And my Opa immigrated from the Netherlands and built up this family business, and eventually my dad took over a part of the business called Systems, which we called the shop, where as children of a Dutch family, we had to go and work, and we also learned how to play there, and I learned how to start building because I was allowed to use the scrap steel and all the machines there on the weekends. As I grew up, I had to decide what to do for university, and I studied mechanical engineering, and this is about as seriously as I should be taken. Just like, nice to have a little fun. I want to just highlight up front some of the concepts that kind of are weaved through what I want to share here. Just kind of keep them in mind as I show you what I've done. The first one I want to bring up is tangibility, the sort of let me see that thing. I think when you say the phrase, let me see that, what people actually mean is let me hold and touch that thing. And that's partly because tangibility and being able to manipulate something with our hands is very useful for building up some kind of sense of what we're actually looking at. But starting up with intangibility here, this is not a value in any sense. It's just a sort of illustrative spectrum of how you can think about tangibility. Desires and insights are in your mind, and they're very ephemeral. You can turn them into ideas and concepts that you can sort of grab onto in your own head a little bit. You can turn those into verbal and textual communications. From there, in the context of making things, you can create designs and drawings which sort of increase the tangibility of your ideas even further. And then you can make digital models, little prototypes with cardboard, whatever you want, to be able to actually kind of get the sense of scale for what you're doing, what will and won't work. And from there, you can actually create objects. You know, you can 3D print things, you can manufacture them however you want. Next concept is garbage collection. It's a little tongue-in-cheek. I don't actually mean programmatic garbage collection. I just mean don't be afraid to try stuff. If you're making things, you will make garbage, and that's okay. It's part of the fun some of the time. I don't mean to literally just go and create garbage. Like, try to make good things, and as you go, some of the things you make just won't be as good as you thought, or they won't work out the way you wanted. But that's okay, because what we're really trying to do when we make things is to explore our way towards solutions. And I want to say that it's worth making stuff even if others can do it better. That's a lot of the things I make, probably all of them to some degree. But I make them anyway because it's a lot of fun and you can just learn a lot of stuff. And quite simply, makers make things. There's no shortcuts. You just have to do it. And some of the things are going to be garbage, and that's totally okay. The concept of motivation, I think, is pretty important to keep in mind as well. I'm motivated by curiosity, a sense of accomplishment. It feels good to have something to show for the work you've done. I like to try to make things to improve my competence and my confidence with a tool or with an idea. I make things for myself, but also I try to make things for other people or make things that can help them make things themselves. I just want to be helpful, and I want to do that by making things. And love is a big motivation for me. A lot of what I make is for helping people who are close to me. So what does it actually mean to be a maker? I mean, it's A maker is one who makes, which isn't a particularly helpful definition. So very broadly, I want to say that a maker turns ideas into tangible objects. Basically, if you have an intangible thing and you increase its tangibility somehow, I would consider that making for the purpose of this talk here. And it's, a maker is more than a person with a 3D printer, just to put that out there. You don't need a 3D printer. A lot of makers, if you're looking at Twitter or whatever, a lot of makers do have 3D printers, but that's not a requirement. No particular tool is a requirement. Just the willingness to be creative and to try and produce something is basically all you need. And so my journey begins, and I'm just going to say it starts, roughly speaking, at CAD and CAM design. I spent time working at the shop, like I said earlier, and I had to learn CAD and CAM design tools, in particular a few CAD programs. I learned SolidWorks, which is a 3D feature tree, sketch constraint-based modeling. All that really means is you pick a plane, you draw a shape on it, you can turn that 2D thing into a 3D thing through extrusions, revolutions. That's a part. You put parts together into assemblies, you've got your 3D model, and from that you can produce drawings that you can send down to the shop, and people can hopefully understand what you want. They can weld it together and build it, or you can build it yourself. I also learned some AutoCAD, which is much more direct modeling. You're drawing lines and circles a little bit more. That's an oversimplification, but for the sake of this, that's fine. And I also learned some proprietary CAM machine stuff, things like 2D nesting programs and toolpath adjustment. You can see in the corner there, that's a 3D toolpath of a CNC laser cutter. So I would like to actually prove that I can call myself a bit of a maker, so I have a few early projects I want to show at this time. On the left there, it's just a scene I decided to make for no reason, cut it out of a tube, and it all like bends into this scene. In the middle here, I modified a walker. My Oma, when she was still alive, there was a time where my Opa could care for her at home, and the walker would have Oma facing outward, but they were more comfortable if she would face inward while she was being moved around. So I made a bracket that would let you just mount the seat the other way. And on the right there is a vent cover. My sister broke her old one and couldn't find the right size at the hardware store, so she sent me a picture of what she wanted and some dimensions, and I made it. I made experimental furniture on the left there. That's all, there's no welding there. It was all bolted together because I thought it'd be fun to pack it up nice and small. I never did because it wasn't actually a good design. But there's an acrylic sheet there that you can actually use as a whiteboard. I set up an infrared camera and made a little infrared pen that you could make a touch screen out of the 32-inch TV that's in there. It didn't work well, but that's okay. It was really fun, and a lot of people thought it was cool. On the right there, I made, with some skateboard bearings, a little skate on a track. So the idea was to put a track up all around the room, and you could hang monitors on it and just slide them around. That was pointless, but it was really fun. So at this point, I've been doing all of this modeling manually, and every project was just start with a fresh sheet and go at it. So I also did more than just my own stuff. I was working and making greenhouse design drawings, that sort of thing. And so I wanted to figure out how to semi-automate some of this stuff, do 80% of the stuff automatically, and the last 20%, that's different for every project. That's where the human comes in and tweaks things around. I actually moved to the Netherlands for a while, and I was working at a company that made pump systems for greenhouses, and this one here is a disinfection unit. Each one of those tubes is a UV bulb, and the water flows through there and disinfects it with a UV blast. Configurations are what SolidWorks called this sort of setup where you can call out in the drawing different things like dimension 1, dimension 2, number of repeated tubes, whatever, the length of the tube. And you put that in the first row of the Excel sheet here. And every row under it will have its own set of values for each thing. And then that shows up as an option in your configuration later. So yeah, you can, it's a fully embedded Excel sheet. In theory, everything works. In practice, that's not always true. Here is an example of the actual thing being built. And on the right, there's a different thing. And I was trying to actually create some documentation so that people could reuse these models. And I just want to call out some of the problems with configurations. The logic of models is hidden in the embedded sheets. If you don't know that there's an Excel sheet driving it, there's nothing explicitly calling it out and showing you right away. You have to know. Logic in SolidWorks formulas, which is a different thing, can directly contradict the logic in a configuration. You know, in configuration A, you can use this formula, then switch to configuration B that had certain expectations, and it can just totally break. Feature toggling, you know, hiding and showing things completely, can break other constraints. There's a high learning curve and difficulty to communicate. And you can reduce the part and subassembly reuse. If you have a part that is highly dependent on the assembly it's in, but you want to use it somewhere else, good luck. It might break things that you didn't even think about checking. So it just became inflexible. And I put in all this work to try and figure it out. It feels really good, you know, to get something that you can drive with a single parameter. It's great. It's really cool. And then it doesn't work when your colleague has to do it and they don't know exactly how or which file to do it in. So it's just not a perfectly viable solution. So I started wondering if there were other solutions. I never really went down this route, but AutoCAD has, or had, I'm not sure it's particularly well used anymore, AutoLisp. At the time, this intimidated me, so I kind of bounced off of it. SolidWorks also has Visual Basic for applications. You can record macros. These are not like Clojure macros. They're harder to work with. Here, for example, SolidWorks Selection Manager .get selected object 6. I don't know what 1 or -1 do. And it feels like it's like the Fast and Furious franchise or something. It's like, I don't know what the other 5 do. It was just hard to work with. So at this point, I started wondering if there were better ways. And I discovered programmatic CAD as a concept. Why programmatic CAD? These were, maybe some of this is idealistic, but at the time, these were the things I had in my head. You can use code as some documentation. Literate programming also as documentation, both for the code and for the domain logic of whatever you're building. You had textual version control, which is better than a big binary blob in some database that, I mean, if you're in a mechanical engineering place, there's a good chance that no one wants to maintain the database. And so it can be hard to set up. And it just isn't totally smooth, to say the least. And also, open tools means no vendor lock-in. That's another nice bonus. So around this time, I should say, I decided to move back to Canada and try working at the family business to become the on-site engineer there. And one of the reasons I made this switch was, there were several, but one thing that really got under my skin was we had set up and learned SolidWorks and then switched to AutoCAD or Autodesk Inventor, which, you know, they are the same kind of product, but you can't necessarily switch them over. The transition's not easy. There's a learning curve. And I thought it was the wrong choice. But I'm not here to complain about any of those things. I'm here to say that programmatic CAD is a compelling thing to me at this stage. So what are some examples of it? OpenSCAD, which has actually featured in some really awesome Clojure talks before. So I won't really rehash that too much, but it's awesome. It's a lot of fun. CAD query is something I found that is really cool. It's a Python library that was tied to FreeCAD and kind of offered a theoretically simpler API for making driven parametric models with code. Honorable mention, Inkscape. If you needed to just do 2D drawings quickly, you can actually use Inkscape. It does SVG, but you can also export DXFs, which you can use in AutoCAD and OpenSCAD and stuff like that. Very useful. These are two examples of, on the right there, just making a model with CAD query. And on the left here, I actually got so into CAD query that I, for the first time, tried to do some open source development. This is a Jupyter notebook, and I made a plugin that would spawn this UI that you could manipulate the parameters, and you could see the 3D model change right in your notebook there. So the literate programming idea was there from the start. Here, I was just practicing Inkscape, and I wanted to make some cool stuff. And I used CAD query exclusively to make that 3D chess set there. At this time, I was still also making weird stuff. This is a really heavy and pointless TV frame to, to reclaim that TV frame from that desk I made. But in the middle here is like a web page that I made documenting the process. It's got CAD query code there. And those are 3JS embedded things. You can actually see the model. That was a lot of fun to work on. It was the first sort of exploration into this idea of interactive documentation. Lots of fun. Here I helped my brother make a chess set with a laser cut pieces there. That was a lot of fun to do. And so I had like an actual job too. Those just are less fun to show. And around this time the pandemic hit, so my brother and I decided to build a squat rack, and we got really strong. And that's just some pictures. There he is welding. There's the frame there. And here is actual work. This here is we call it a lifting jack set. What this is for is helping to manufacture heating storage tanks for greenhouses. They're big water tanks, and you build them up one ring at a time. So here's an example. You set up the jacks on the inside. You weld the steel sheet all the way around. Then you lift it, and then you weld the next layer on underneath. It's not pictured here, but you'll also have the roof on before you're lifting everything. So you don't have to like go up and put the roof on at the end. So it was around this time that I also had some other career realizations, and I actually quit working at the family business and just took a little bit of time. And what I did at this point was scratch the creative itch, and I went all in learning Clojure. And why Clojure? Because I was working on Python stuff before. I'm self-taught, so when I say that I learned Clojure, people are sometimes a little surprised to hear that's sort of the first real foray into programming that I actually took. So why? Functional programming really made more sense to me. That open source thing I was working on, I hit a wall when I couldn't understand the class hierarchy, and someone had posted a bug, and I didn't know how to fix the thing I had made. And I thought, okay, it's me. It's not the code. I don't know enough. So I stepped back and figured out what I should learn next. And eventually Clojure came up. SCAD CLJ, it was one of the first libraries of code that I actually read and could understand. That was a big deal for me. It was really encouraging. And I thought, hey, if I can actually understand this, like I can read the whole code, the whole library. It's not huge, but I understood it. That was great. By the way, here, this is an example. This sphere, this is an SDF, sign distance field. It's a higher order function. You set a sphere with a radius, and you get back a function. You can put in a 3D point, and it'll give you a distance to the surface of that sphere, and you can use it to render. And I'm just putting that out here because that was the first thing that really was tangible in my mind for why on earth higher order functions are a big deal. And that was just so cool. Like it's just something I could completely picture. It just made perfect sense to me. The REPL is always really awesome to use. And to bring up tangibility again, I think the REPL is a really good example of something quite tangible. You can type in code and just see what happens. It's right there. I mean, you can't like grab it with your hands, but you can just type it out and you get a result right away. A lot of the older code still worked, which makes examples pretty consistently valuable. Python, I spent always a little bit worrying if I was reading code that wouldn't actually run or make sense. A little bit of that is, I was new to all this, so grain of salt. And the people who use it seem to know what they're doing. So, when in doubt, follow the people who seem to know what's going on. But keep an eye open in case you're following the wrong people. But I wasn't, so. And so the creative itch, I'll just give some really quick examples here of what I kind of was talking about. Here, I have a tattoo. And this is one example of making something less tangible, I guess. But I traced it out with the iPad pencil, something that's a really good example of tangibility. Made a 3D model and animated it poorly with FFmpeg. It was just, I don't know why I did that. It was just really fun. I thought it was cool. There's some OpenSCAD stuff on the right. And on the left here, I did a really bad ray marching implementation. And you can see the output directly in the REPL, which was really fun at the time. It's really bad because it's slow and I didn't optimize it. I just wanted to see if it would work. But that's actually, the sphere SDF. That is an SDF right there, sign distance field. You can do all kinds of neat stuff with it. Here is a Clojure script thing I made. I like bananagrams, so I made a solitaire clone bananagrams. This is me playing it really quickly just to prove that it works. I made a prototype hydroponic system with my friend. It's very prototype, as you can see. That was a lot of fun. Here's some examples of some like generative stuff I was just playing around with. All of this is with Clojure, by the way, and SVG, OpenSCAD, just whatever I could get my hands on, really. Here I was in IKEA. I saw this set of drawings, and I thought, I wonder if I could make a little program that kind of creates that sort of art style, and I could. So you can see some examples there. I bought a pen plotter, and I used Clojure to make a bunch of art things there. SVG is really conducive to these like line style works, and it's, I think, really fun. And perhaps one of the cooler things that I'm really proud of is I worked with my mom, and still do now, on helping her make quilt patterns. So she quilts constantly. And she now will do the designs, and she'll like do little diagrams and stuff like that. She'll type up the instructions. And I will create the diagrams in SVG. And I don't do it this way now, but I use Hiccup and an SVG library I wrote to build out the diagrams. Here's another example. On the left is the diagram, and on the right is the actual quilt my mom made. So tangibility there. And we're getting closer to the present. As I'm doing all of this, I was also really keen on interactivity. So here's some examples of things I made. This is a Psi interpreter and code mirror thing I made where you can edit the code block, and you can, if you add a def, it'll pop a new parameter at the top, and you can slide it, and you can see the result there. This is another example of a thing that's cool, very prototype only. Like it's not very portable, it's not easy to set up, and I don't know where the code is. So it was a worthwhile experiment though. And on the right is a clerk notebook, which I will absolutely be diving into more of that stuff now that I know a little bit more. The idea, once again, of those interactive documents with 3D models and stuff is very compelling to me. And here's one other example. This is a bidirectional clerk notebook. That's one thing in the previous example that still bugged me. You could write stuff in the REPL, and it would show up in clerk, but if you manipulate stuff in clerk, you don't necessarily get it back into your file. So this was an attempt to create a bidirectional link. If you change something in the clerk notebook, it actually writes back to your file. The way I implemented it could be improved, as like I'm saying, the garbage collection is very real. But that brings me to approximately now, and I'd like to take a moment to switch to a demo where I've worked on something and I think it'd be really fun to show it. Let's see. Sorry. There we go. Okay. So let me zoom this in, get things going. Okay. So I actually did have the hydroponics thing working here, I think. No. Anyway, this here is OpenSCAD. Like I said, I'm not going to spend a ton of time doing it, but this is, I want to point out something quickly with OpenSCAD that is a bit of a weakness. One, this rendering looks incorrect, but if you actually render it properly, it does have a proper closed face there. So the rendering can be a little strange with really thin walls. That's okay. The bigger issue is actually that you can't export step files or like industry type files. It's a lossy format, STL. What it does is mesh your whole thing. And so instead of a circle, it's actually a polygon with straight edges, which can be fine for 3D printing. In fact, OpenSCAD is great for that sort of thing. But it's not necessarily what you want to be doing your greenhouse designs in. So I did cobble together this little step exporter that actually does work in FreeCAD, but that's probably not worth showing right now. What's more exciting to show is this idea of an interactive tool that I'd like to show now. And I'm going to do that in this namespace. This is a little project I'm working on, again, prototype phase, called Solenoid. It's a little web app sort of thing that uses HTMX. HTMX is a thing on the front end, you hit an endpoint, HTMX sends HTML back, and it renders it for you. It's very simple, and it's a lot of fun to work with. So, what is it? I have a few macros. I'm going to do let view and show that first. I'll just put a little paragraph, hi. If I evaluate that, it spits this card in here. By the way, if you compile your Emacs correctly, you can get an XWidgets web browser right in there. That's what this is, which is, I think, pretty neat. So this is a view here. Anything that you can render as hiccup, you can put in here. So you can do SVG as well, which I'll make great use of in just a moment. Another thing you can put in is let controls. And I'm going to just do A, and I'm going to do 1, just to demonstrate very quickly. And that will create this control thing here, and you can manipulate the control, and you see the result displayed right here. It drives, it's all driven by it. And if I go back into the REPL and def A as that result, I can deref it and get the rendered value there. And so, just with that alone, it is rendered, so it's not like the true value. What you can use is meta, and you can put whatever you want in the meta map and pull out the real value that way. So with those building blocks, I made this. Oh, great. Let's see if it worked anyway. Yes, okay. We'll start here. Nope. We'll start here. This is an example of something I'm working on for my mom. This is a quilt design that's in progress. And I should maybe zoom this in if I can. There we go. So this is just a note. You can move it around. You can X these things out. This is a set of sliders that control the view, which I have to fix. Okay. Okay. So as you can see, these are the idea of all of this is to, as you're working on something, you can write out these defs, you can evaluate these and get something that you can play around with right in, you can do it here, or you can do it in, on a second monitor or something like that. And then you can deref it and you can get those values and keep working on it. The reason that's not working is because I think I have a value that's not real anymore. I must have deleted it. So let me just fake it. Okay. That's the risk with these live things, I guess, eh? The pressure's way off when you're just messing around at the airport or, whatever. And, okay, I need this. Promise this looks pretty cool. So this here, this is just, I had a control in here that I didn't actually use, so I must have removed it and, okay. In my head, this went a lot smoother. Sorry about that, everyone. Perhaps there's another way. Let's see. Okay. Okay. I think we're back in business. Thanks for bearing with me. Okay, so what we have here is a set of controls that I've built up for the purpose of controlling this here. So this particular design pattern is focused around the idea of intersecting circles here. So in this visual output here with this green leaf-looking thing, what's actually happening is I'm patterning out the circles, and I've got inside the red circles, I'm calculating all of the intersections that each of those circles has. And I've got, because I don't actually want all of those, I just want to sort of pick out little pieces at a time, and then later on go back into the REPL and manipulate the polygons, just get the list of points, do whatever I want on it, spit it back out in a new thing. And so this, jumping ahead a little bit, is the end result here. And I saved this out and went to Inkscape and scaled it up to the right size. And I got a text from my mom today saying she loves it. She printed out the pattern. It's called English paper piecing. She glues the paper onto the fabric, cuts out the fabric, and sews it all together. So at the end of the day, this could be like an actual quilt. And it's just a lot of math manipulation and, well, not even math, it's geometry and just fiddling around. The point of this tool is really to show that it's really helpful to get your hands on something. And let me show you what I mean by something like that. Here, you can bring things over, and this is called the excluder. I'm just gonna, this isn't, like final. What I actually want is better drawing capabilities on all of the renders that I have. But for right now, literally just overlapping things is helpful. So I can move this and it reacts right away. And this excluder was meant to remove all of the intersection points that show up on the inside here. And because I don't have a particularly robust like polygon reordering, point reordering system, I just kind of naively made it try to do a sort of hull. It's just helpful to have a quick tool that says, I want these and just not those. So using the includer and excluder, I'm trying to sort of convey tangibility. Even with an imperfect tool like this, like I said, prototype, you can get quite a bit done if your stuff doesn't fly off. There it is. And okay, so I am going to, I'm sitting here designing this and I'm thinking, okay, what might be a cool piece to cut out next? What might be useful as a piece of the puzzle here? And if I look at this top sort of diamond here, I might want that. So I'll go ahead and highlight it. And as you can see, even before I get there, that's kind of a cool shape. Maybe that's useful. Keep that in mind. And maybe I'll go to it later. But here we are. We've got the polygon that's just those 4 points. And yeah, you can see it's not following the curve because it's just a straight polygon. But for the purpose of iterating through this design, totally fine. I'm not going to worry about that. And now I can head back to the REPL. And I know that I've got that. Just get rid of that there. Don't need it for right now. Here is an example. I can evaluate this, and these are the points that I just selected from there. If I edit this and I grab a different set of points, I do this again, it's a different set of points right away. And I can copy that, put it in a def, I can do whatever I want. I can save it and keep it. And I built a few little helpers here, so you can switch between tools back and forth nice and quick. So if I show shape and put that in there, you can see that in fact you've got the right shape. Because it is hard to know, you've got a list of 2D vectors there. I mean, if you work with this stuff long enough, you can maybe kind of figure it out intuitively if you redraw it in your head, but just get the computer to do it, it's much easier. And so this is the process I use to build up the different base shapes here and to produce what you see in this final one here, which so colors pending. My mom is the one who picks the actual fabric. This is just programmer colors. But it's all interactive. You can work with it. You can play around with it. And I, just for fun, put other controls here so you can modify the shape. Like you could imagine a variant of this thing that's a 6-leaf flower instead. And in this case, these inner flowers line up nicely. You can explode it out or bring it in and try to find, I don't know, different intersection points that look cool. And this is the kind of thing that's really helpful when you know roughly what you want to make, but you also don't, you've got a vision and maybe you can get there, or maybe there's something cooler along the way. This is exactly what this tool is for. I do want to also show, one final thing, tie this up. I mentioned OpenSCAD, and I'm motivated by Programmatic CAD a lot. So I have one other thing here. This is another example. If it'll work, I think it will. That's nice. since HTMX just sends HTML over, if you can find something that works like web components or something like that, you can, kind of get anything or nothing. I thought this was working. Okay. Okay. There we go. 1 second. Let's try this. Do I have an internet connection? There we go. Okay. So this is a library I found called XITE, and it uses the X3D spec, and it's an XML. You can use XML to specify these 3D models, and this is a pointless example, but it shows the interactivity, and you get the 3D models and everything. So this tied with my the 2D drawings that you saw in the other example are where I want to take this next, because I do think you can make some pretty useful 2D and 3D tools with it. You get this interactivity here. It just is fun. This also scratches the itch for me in terms of the generative tools, because you can use it for work and play. And that, I think, is going to be a good place for me to end this. I could fiddle with all of this and mess around and make my code break in front of you all for much longer. But I think I'm pretty happy ending on this example right here. And I'm really glad that you all came and listened to my talk. Thank you very much.